Recently captured images from the James Webb Space Telescope have left scientists in awe. Instead of broadening our grasp of the cosmos, these images have revealed a disconcerting truth. Our current understanding of the universe's early stages is insufficient. As the Big Bang Theory encounters its limitations, it prompts us to explore new ideas about the origin of the universe. This raises fundamental questions about how and why the universe came into being. This recent discovery is compelling even the most experienced astronomers to reconsider the Big Bang and delve into the groundbreaking implications of this revelation. Let's re-examine the Big Bang concept itself. Contrary to popular belief, the Big Bang was not an explosion within pre-existing space but the very creation of space itself around 13.8 billion years ago, along with matter and time, from an initial singularity. In the fields of physics and astronomy, a singularity refers to points where gravity is so intense that space-time curvature becomes infinite. Today, billions of years after the universe's inception, our cosmic home is part of an ongoing process. For scientists, this represents a fundamental characteristic of the universe from its very beginning, its seemingly endless expansion. However, it's important to understand that the cosmos is not expanding into pre-existing space. Rather, space itself is continuously growing. According to traditional theories, the first stars began shining between 200 and 300 million years after the Big Bang, signaling the end of the so-called Dark Age. This was when the earliest luminous celestial bodies coalesced to form mature galaxies. However, the rapid growth of these galaxies remains an unresolved puzzle. A crucial clue emerged from the first images captured by the James Webb Space Telescope in July 2022. Experts revealed that the telescope had detected several galaxies, some of which existed around 300 million years after the universe's formation. Yet, compared to the galaxies that formed millions of years later, these early galaxies were much smaller and less massive. This observation aligns perfectly with the scientific model accepted by researchers. The density of matter in the young universe was too low to produce galaxies as large as those seen today. What began as the discovery of 6 bright, redshifted luminous spots by James Webb has sparked one of the most significant astronomical crises in recent times. Although these newly discovered galaxies are of similar age to previously recorded galaxies, they are nearly as massive as our Milky Way. This has created a fascinating mystery in astronomical research. After analyzing a series of images taken by the near-infrared camera, experts identified these light sources. Using redshift, scientists calculated that the light from these objects took more than 13 billion years to reach Earth. Thus, we are observing structures that already existed around 570 million years after the supposed Big Bang. By analyzing the characteristics of these structures, it was concluded that the Webb telescope had captured 6 extremely early galaxies in the image. Surprisingly, these galaxies were so massive that they defied conventional cosmological expectations. Instead of finding the anticipated dwarf galaxies, structures were identified that were nearly as massive as our Milky Way, despite having formed early in the universe's history. If we continue analyzing the data collected by the James Webb Telescope, this gravitationally bound cluster of stars was already more than 10 billion times the mass of the Sun at that time, with one potentially surpassing the 10 billion solar mass threshold. However, even considering this possibility, the mystery is not fully resolved. Even in this scenario, there would be significantly more mass in the early universe than previously thought, posing a conundrum. The detected objects contradict nearly all conventional cosmological theories. Even if only one of these galaxies proves genuine, it would challenge our previous assumptions about the formation of such structures. Additionally, the density of matter in the early cosmos would have had to be up to 5 times greater than previously believed to explain this phenomenon. Another equally mysterious explanation suggests that these galaxies developed in a manner still completely unknown to us. These discoveries and the debates surrounding the Big Bang are leading more researchers to question this theory. Many astronomers with alternative views are frustrated that their perspectives are not being heard in scientific journals. Even those who express doubts about existing theories are often labeled as eccentric and ungrounded. However, it is undeniable that even proponents of the Big Bang theory are constantly faced with unanswered questions. These include fundamental issues such as why and how, 13.8 billion years ago, something came from nothing. Can something truly originate from nothing? Or was there an initiating event? Or was it all just a coincidence? Stephen Hawking noted that the concept of time as we know it began with the Big Bang, meaning this process could not have been triggered by an external factor or entity. A similarly contentious question involves the uniformity of radiation density across the cosmos. Regardless of direction or distance, on a larger cosmic scale, we find similar densities and distributions of galaxies, nebulae, and radiation everywhere. Conservative scientists attribute this to the theory of cosmic inflation. However, others extend this assumption with a theory of chaotic inflation. This idea posits that inflation has only ceased in some regions, like bubbles, while continuing infinitely elsewhere. This suggests that multiple universes form within these bubbles, each with its own unique physical laws. Within this framework, a crucial question arises. What if the cosmos does not represent the complete whole? And even more provocatively, what if another universe existed before ours? In that case, the Big Bang would be part of a larger cycle. This perspective suggests that our universe is part of a multidimensional structure, with the concept of an eternal cycle of collapse and rebirth of the universe. However, this is not the only perspective in cosmology. Apart from the Big Bang theory, in 1955, an article appeared in NASA's Cosmic Times suggesting that there may have never been a Big Bang, as the universe could have existed eternally. In this view, the expansion of the cosmos would be non-existent, and the continuous formation of matter could create the illusion of constant cosmic expansion. Another intriguing yet controversial theory arises from quantum physics and string theory. Some experiments allegedly suggest that our universe and everything in it do not actually exist. In simple terms, what we perceive as the visible universe could be a flat hologram projected onto a sphere. Thus, our reality might be the result of a higher simulation. While this sounds like the plot of a science fiction movie, it can be linked to the Kardashev scale, which measures a civilization's level of development based on its ability to harness energy. A Type 3 civilization, capable of fully harnessing the power of an entire galaxy, could create a perfect simulation. However, determining the truth in such a scenario is highly complex. Delving into cosmology and the origins of the universe leads us into profound mystery and ongoing scientific exploration. The recent images captured by the James Webb Space Telescope have reignited questions about the very nature of our existence, challenging established theories and prompting scientists to reassess fundamental aspects of cosmological understanding. At the heart of this inquiry lies the Big Bang theory, a cornerstone of modern cosmology. According to this theory, approximately 13.8 billion years ago, the universe emerged from an unimaginably dense and hot state, rapidly expanding and giving rise to space-time and matter as we know them today. This cosmic event is not merely an explosion within pre-existing space, but rather the very origin of space itself. The concept of a singularity, where gravitational forces are so intense that space-time curvature becomes infinite, underpins our understanding of this primordial epoch. Yet, the discovery of early galaxies by the James Webb Telescope challenges our assumptions about how quickly structure formed in the universe's infancy. These galaxies, detected within a few hundred million years of the Big Bang, appear surprisingly mature and massive, contrary to expectations based on current cosmological models. One fundamental question raised by these discoveries concerns cosmic inflation. According to prevailing theory, inflation occurred within fractions of a second after the Big Bang, causing the universe to expand exponentially. This rapid expansion would explain the uniformity of cosmic microwave background radiation observed across the universe today. However, recent findings suggest complexities in the early universe's evolution that may require revisions to inflationary models. The formation of galaxies, like those observed by the James Webb Telescope, challenges cosmologists to rethink the conditions and processes that govern the universe's early epochs. These galaxies, already substantial in size and mass so soon after the Big Bang, imply a density of matter that exceeds previous estimates. The puzzle deepens when considering how such large structures could form and evolve in such a relatively short span of cosmic time. Moreover, the discovery of these early galaxies raises intriguing questions about the nature of dark matter and dark energy, two elusive components that make up the majority of the universe's mass-energy content. While dark matter is thought to provide the gravitational framework necessary for galaxy formation, the distribution and properties of dark matter in the early universe remain uncertain. In parallel with these astrophysical mysteries, theoretical physicists are exploring alternative models of cosmology that challenge the traditional Big Bang paradigm. Some theories suggest that our universe is just one among many in a vast multiverse, each with its unique physical laws and constants. These ideas, stemming from developments in string theory and quantum cosmology, imply a more complex and interconnected cosmos than previously imagined. One concept gaining traction is eternal inflation, where universes continuously emerge from a larger inflating space. This theory suggests that our universe could be just one bubble among countless others, each with its distinct properties. The challenge lies in finding observational evidence to support such speculative ideas, as they push the boundaries of empirical verification. Another provocative hypothesis is that our universe exists within a simulated reality, akin to a computer-generated simulation. This idea draws parallels to advancements in artificial intelligence and computational science, where simulations can replicate complex systems with astonishing accuracy. If true, our perception of reality as a tangible physical universe could be fundamentally altered, raising profound philosophical and scientific questions about the nature of existence. Moreover, advances in observational astronomy continue to reveal the universe's vastness and complexity. Telescopes like the James Webb Space Telescope, with its unprecedented sensitivity and resolution, are expanding our understanding of cosmic history and challenging our assumptions about the early universe. The discovery of massive galaxies so soon after the Big Bang suggests that we may need to revisit our models of galaxy formation and the role of dark matter and dark energy in shaping the cosmos. As we grapple with these new discoveries and their implications, it's clear that our journey to understand the universe is far from complete. The mysteries unveiled by the James Webb Space Telescope are just the beginning of a deeper exploration into the origins and evolution of the cosmos. Whether we eventually confirm or revise the Big Bang theory, or uncover entirely new frameworks for understanding the universe, the pursuit of knowledge continues to push the boundaries of human understanding, inspiring both wonder and curiosity about the cosmos and our place within it.